Alright guys, let's think about our next section, 5.3. 5.3 you talk about exponential function. What does it mean for exponential function? It must be a function in the form of exponent where the base is a constant, the power is the variable, but the base must be bigger than 0, and of course we don't want it to be 1 either. That would make no sense, it just be a constant. So we can do this. Now there is a whole lot of concept here that we can think about. If you think about the drawing here, okay, if a greater than 1, that means the graph gonna look like this. It's gonna blow up very fast. If something bigger than 1, when x get really big, power something really big, if the base is bigger than 1, let's say 2 to the million, is gonna be very big. But if x equal to 0, this guy here is always a 1. Okay, it's always a 1. But if the base go bigger, you're gonna have something like this. If a go big, so this is a is big. Okay, but if a is smaller than 1, you will have something like this. And it would be decay if a is smaller than 1. So this is the case that a is less than 1. So you can think about playing the graph like this a little bit so that you can justify what this is. The nice thing about this domain here is the domain of this type of function always all real number, but the range of this particular type of function is when y are greater than 0. This function will never give you equal to 0 whatsoever, will never equal to 0. There's no way you can find an exponent, let's say 2 to what power is 0? Never, never, never 0. Alright, some of the property that you want to remind you. Property of exponent is the following. When a to the 0 is always 1, okay? When a to the power m times a to the power n, what do you do with the power? You add them, okay? You add the power. But when a to the power m divided by a to the power n, you use the top one minus the bottom one. Or when you have a case that a to the power m and then to power n to the power, what you do is you multiply them. Okay, and also if you have a square root n of a to the m, this is a to the m divided by n. This thing here must be from this root. And if you have a times b to the m, this is a to the m times b to the m. And if you have a over b to the m, so you want to do is power each one separately. Okay, and one last thing, if you have a to the minus power, you can move back and forth top to bottom by just change the power to the bottom piece of that thing. So this is all the property and all the law of exponents. What can you do with this type of exponents? Okay, what can you do with this type of exponents? Please play around with the graph. I'd like you to graph this guy and try to understand. Well, first of all, graph y equal to 2 to the x. And then I want you to do graph y equal to 3 to the x, y equal to 10 to the x. And then again, let's do y to 2 to the x, and then y equal to 2 to the minus x. Okay, this is equivalent of 1 over 2 to the x. Want to use the property, why is this thing is the same. Okay, and plot y equal to 0.001 to the x and see what does it look like. Okay, let's try to play around with this number. But there is one special number in this area here. E, for those of you who might know what E is, on your graphing calculator. This notion involves taking a limit that you're going to learn in Calc 1. 1 plus 1 over n to the n. So what happens when the increasing a little bit more than 1, but is gets smaller and smaller to the power of infinity. So what is that value turn out to be? And that value turn out to be your favorite E, turn out to be 2.71 8.1, 8.2, 8 blah blah blah, right? Just mostly we commonly known as 2.71. So you can try to play around with this. But in here, once you have exponential function, sometimes you can ask like, when is this exponential function equal to another? So here is the rule of solving exponential equation. So let's talk about solve exponential equation.